Hey, welcome back to the channel. I am Code Hero, staff software engineer, and this channel exists to help you grow as an iOS developer. Before we get into it, please hit subscribe and tap the thumbs up button right now. It costs you nothing, and it helps more developers find this content. Today we are going to look at the real numbers behind Swift in the App Store, how Xcode and Swift versions are always tied together, and why that matters for your team, what you must think about before you migrate to a newer Swift version, and what the trajectory of this language looks like all the way through 2030. Let us get into it. Let me give you the context first. Apple does not publish a public breakdown of how many App Store apps are compiled with each specific Swift language version. That number simply does not exist as a first-party public report. What we do have is iOS adoption data, Xcode submission requirements, and developer surveys. From those three sources, we can build a very clear picture. As of March 2026, iOS 26 is installed on nearly 60% of active Apple devices, based on monthly tracking. iOS 18 had reached 20% adoption by 2026. That matters for Swift because Apple ties Xcode submission requirements to iOS SDK versions. Starting April 28, 2026, every new App Store submission must be built with Xcode 26 and the iOS 26 SDK or later. That means any app updated from 28 April 2026 onward is being compiled by the Swift 6 compiler toolchain. Now here is the distinction that most developers miss. Being compiled by the Swift 6 compiler is not the same as running in Swift 6 language mode. The Swift version build setting in your target controls the language mode. The compiler is Swift 6. The language rules you are using are Swift 5. This is intentional. Apple gives you a migration window. Most live App Store apps in early 2026 are compiled with the Swift 6 toolchain, but written in Swift 5 language mode. That gap is what the industry is closing right now. Based on developer surveys from mid-2025, roughly 65% of iOS teams have adopted Swift UI, which is a strong proxy for modern Swift adoption in general. Swift 6 strict mode adoption is still in early stages across most teams. The acceleration is happening through 2025 and 2026 as the ecosystem pressure from Apple builds. The honest answer to the question of what percentage of apps are on each Swift version is this. Almost all new submissions use the Swift 6 compiler, but most are still using the Swift 5 language mode. That will shift gradually through 2026 and 2027. This is the thing that trips up almost every developer who is not paying close attention. Every Xcode release ships with exactly one Swift compiler version. You do not get to pick the compiler independently inside Xcode. The compiler is bundled. Period. Here is the pairing you need to know as a reference. Xcode 13, Swift 5.5, introduced async, await, and actors. Xcode 14, Swift 5.7, introduced Swift regex and navigation stack. Xcode 15, Swift 5.9, introduced Swift macros and the observable macro. Xcode 16, Swift 6.0, introduced strict concurrency enforcement and Swift testing. Xcode 26, released September 2025, ships with Swift 6.1, adding package traits and productivity improvements, introduce agentic code. And the latest, Xcode 26.4, released March 24, 2026, ships with Swift 6.3, which refines concurrency diagnostics and continues the data race safety improvements. This is the current production toolchain as of today. The Xcode upgrade pattern has been consistent for over a decade, and it will not change. WWDC in June announces the new Xcode beta. The stable release ships in September with the new iOS version. Apple sets the new minimum Xcode requirement for App Store submissions the following April. You have roughly 6 to 8 months to test and adapt before compliance becomes mandatory. The practical implication is that your CI system needs to handle Xcode upgrades as a documented workflow, not a surprise. Whether you use GitHub Actions with macOS runners, Bitrise, or Xcode Cloud, pin your Xcode version explicitly in every pipeline configuration. Test the upgrade on a branch before the deadline forces your hand. This section is the one I wish existed when I did my first major Swift migration. Whether you are moving from Swift 5 to Swift 6 today, or preparing for whatever comes next in 2027 or 2028, the checklist is the same. First, audit every dependency. Every third-party library, every internal SDK, every Swift package has its own Swift version setting. Before you migrate your app target, verify that your dependencies support the new Swift language mode. The Swift Package Index tracks Swift 6 compatibility per package. Use it before you start, not after you hit your first compile error. Migrating your app to Swift 6 mode while a dependency is not ready will surface module boundary sendability warnings that you need to understand and plan for. The good news? Your app target and your dependencies can migrate independently. Second, understand what actually changed in the version you are adopting. Not every Swift version bump is equal. Swift 3 was syntactically breaking, almost everything renamed. Swift 5 brought ABI stability with minimal source changes. Swift 6 is not syntactically breaking, but it is semantically breaking if your code has concurrency patterns that are not isolation safe. For Swift 6 specifically, every breaking change is about concurrency. If your app has no async code and no shared mutable state across threads, your migration may be straightforward. If your app is heavily concurrent with a legacy Grand Central Dispatch architecture, you are looking at a significant project. The most common pain points are global singletons that are not actor isolated, delegate callbacks that cross actor boundaries without annotation, and third-party SDKs that have not yet marked their types as sendable. Third, enable strict concurrency warnings before committing to the migration. In Xcode, go to Build Settings, find strict concurrency checking, and set it to complete. Do this while still in Swift 5 mode. This surfaces every warning your code would produce in Swift 6 mode without actually breaking your build. Treat this as your migration preview. Count the warnings, categorize them, build a plan. Fourth, if your app is modularized, migrate module by module. Each Swift package and each target can independently opt into Swift 6 mode. You do not flip one switch for the whole project. Start with your lowest level utility modules. Those typically have the fewest concurrency dependencies. Move up to your domain and feature layers once those are clean. Leave your UI targets for last. This is one of the strongest practical arguments for modular architecture and clean architecture in general. It gives you the seams to change things incrementally rather than facing one enormous project-wide migration all at once. Fifth, train your team before the migration, not during it. I have seen this pattern repeatedly. One engineer learns Swift concurrency, does the migration, and then the rest of the team has to figure out during code review why their pull requests are failing on actor isolation errors they do not fully understand. That is expensive in time and in team morale. Invest in team training before you flip the language mode. Actors, sendable conformance, and main actor isolation need to be understood by every developer touching the codebase, not just the one who planned the migration. Sixth, check your minimum iOS deployment target. Some Swift concurrency patterns require a minimum OS version at runtime. Full async, await, and actor support requires iOS 15 or later. If your app still supports iOS 14, some concurrency patterns require workarounds or back compatibility bridges. This is where decisions made years ago about minimum iOS support directly determine your migration cost today. The lower your deployment target, the more back compatibility work you carry. Seventh, always have a rollback plan. Migrations on live apps need a fallback. Use feature branches. Pin your CI to the current stable Xcode during the migration branch. Do not merge until you have end-to-end test coverage running in the new language mode. TestFlight is your safety net before every language mode change ships to production. Use it every time, without exception. Now let me step back and give you the broader view. Swift 6.0 landed in September 2024 with strict concurrency as its defining feature. Swift 6.1 shipped in March 2025. Swift 6.3 shipped in March 2026 bundled with Xcode 26.4, refining diagnostics and improving the developer experience of the concurrency model. Looking at the trajectory through 2030, a few themes are very clear. The concurrency model will keep evolving. Custom executors, improved interoperability with Objective-C concurrency, and a possible default main actor language mode are all actively discussed in Swift evolution proposals. The direction is clear. Concurrent code becomes the default. Incorrect concurrent code becomes impossible to compile. Each point release of Swift 6, including 6.1, 6.2, and now 6.3, is making the compiler smarter and the warning messages more actionable. The migration pain you feel today in Swift 6.0 is noticeably less in Swift 6.3. That improvement will continue. Swift is officially a multi-platform language. It now targets Linux, Windows, WebAssembly, and as of October 2025, an official SDK preview for Android was announced. For iOS developers, this matters because your business logic may increasingly be Swift code that runs on both a server and a client. Server-side Swift is a growing reality, and your fluency in actors and concurrency safety becomes directly transferable to that context. Swift macros, introduced in Swift 5.9 and refined through 6.3, are still in early adoption across the ecosystem. Between now and 2030, expect macros to become as foundational as property wrappers and result builders are today. Libraries and frameworks are increasingly being designed around them. Your ability to read, write, and debug Swift macros will become a professional expectation, not a specialty skill. Apple has been consistent for over a decade. New Xcode every September. New submission requirement every April. Between now and 2030, you will face roughly 4 more mandatory Xcode upgrades. Each one arrives with a new Swift compiler. The teams that handle these smoothly share 3 traits. Their CI configurations pin the Xcode version explicitly. Their codebases are modular enough to absorb incremental changes. And their culture treats compiler upgrades as planned work, not emergency incidents. We do not know when, but Swift 7 will happen. The pattern from Swift 4 to Swift 5 to Swift 6 shows a major release roughly every 4 to 5 years when the language model shifts significantly. Based on that cadence, Swift 7 is a reasonable projection for the 2028 to 2030 window. If Swift 6 made concurrency strict by default, Swift 7 will likely make something else strict by default. Memory ownership and the work already done on non-compilable types and move semantics are the clearest candidates. The skill that ages well is not knowing specific syntax. It is understanding the model deeply enough that you can read a Swift evolution proposal and know how it will affect your codebase before the compiler forces you to find out. Here is the full summary. Apple does not publish Swift language mode distribution. Every Xcode upgrade is also a compiler upgrade. Plan for it. Do not react to it. Before you migrate, audit your dependencies, enable strict concurrency warnings first, migrate module by module, train your team before not during, check your deployment target, and always have a rollback plan. And through 2030, the teams that thrive will not be the ones who waited for the compiler to force every change. They will be the ones who understood the direction early and moved deliberately. If this video helped you, please hit the thumbs up button right now. Subscribe if you have not already. This channel is built specifically for iOS developers who want to operate at a higher level. Drop a comment below. Is your team already running in Swift 6 mode, or are you still in Swift 5 mode with the Swift 6 compiler? What is the hardest part of the migration for you? I read every single comment. See you in the next one.